Okay. Hi, good evening, everyone. I'm Nadeem from HFCL. For those of you who are not familiar with HFCL, it's an OEM. We make access points, switches, unlicensed band radios, FWA CPs, and a whole bunch of other things. We have a stall across the hall. You can talk to Ajit and his team who will explain to you more about our products. The unique thing about HFCL is it is a company which embodies the spirit of Make in India, both in the letter and spirit, right? So all our products are designed in India, manufactured in India, but they are made for the global market, of course. So today I'm going to talk about some of the learnings from one of the very large-scale Wi-Fi deployments which happened in the Kumbh Mela in the month of January and February 2025. So most of you are familiar with these numbers and dates. Just to recap, this event was spread over 45 days. So it started around middle of Jan and went on till the end of February 2025. And this is geographically also spread over a fairly large area, almost 12 kilometers of bathing ghats where the pilgrims gathered and took the dip during the course of this event. And as per government estimates, the total footfall was around 660 million. So just to put this in context, the population of United States in 2024 is 340 million. So it's almost like twice the population of United States, which is the amount of footfall that was experienced at this event. So the challenge we had was to deploy a Wi-Fi network which not only is geographically spread, but also able to cater to a really massive footfall of visitors day over day over day. And since this is a makeshift arrangement, so we are not deploying Wi-Fi in a stadium, which has a built-up area where you can mount APs, put cabling, switches, and all that. So this is and also an open area, open to elements, and all kinds of disruptions are possible. So the network that we deployed for a telecom operator, almost 400 plus access points. These are all outdoor access points mounted on makeshift poles. And the use case was mobile data offload. So this was not like a hotspot network where you could log into a web portal and enter your phone number, get an OTP. This was purely for mobile data offload. So almost, I think, although we had a couple of SSIDs for management, but from a user perspective, this was purely MDO solution. So anybody who had a SIM card which belonged to the service provider for which this network was deployed would be able to use this network. And since this is a temporary network, the possibility of digging fiber to backhaul the traffic from the APs to the core network was not there, and hence the backhaul was provided through what we call as unlicensed band radios, or UBR, right? Which is again Wi-Fi based radios but designed for backhaul. So these are essentially point-to-point radios operating in 5 gigahertz band, which are providing the backhaul connectivity from the cell site or the tower to the core network. So in terms of how people engage with this network, obviously the primary purpose of the visitors to this event was spiritual in nature, but in our daily lives, communication is as important as water or other basic necessities. So we had almost 2.5 million unique clients which connected to this network over the period of this 45 days. And as we'll see in the next slide, we peaked at around 250K unique clients on a given day. And almost 100 TB of data was transacted through this Wi-Fi network over this duration of 45 days. So if we look at some of the statistics that I've collected from the data that we got, so if you see in the beginning, this one, sorry. Yeah. So initially you see, a little bit lull, but as the, event progressed, we saw that almost, every day, more than 1.5 TB of data usage or data consumption aggregated over all the access points that we deployed. And interesting thing you see here is that out of all the data that was consumed, only 1/4 of it was on the 2.4 gigahertz band. So nearly 75% of data was over the 5 gigahertz band. which kind of tells us that, the 5 gigahertz band is really crucial for Wi-Fi to work. For obvious reasons, because you have more spectrum, somewhat more cleaner than 2.4 gigahertz band. And also from device ecosystem, obviously, the support for 5 gigahertz has been increasing more and more. So we see, for obvious reasons that most of the data consumption is going over the 5 gigahertz band. When we look at the client distribution, so we find that even though most of the data was consumed over the 5 gigahertz band, but you still find that number of sessions that were established, fairly large number still on the 2.4 gigahertz band, which is typically what we saw is that a lot of short-lived sessions, because coverage is 2.4 is better, you would connect and then disconnect. But in terms of data, most of the data is going over the 5 gigahertz band only. And if we look at what protocols were being used by clients, so interestingly, still a fairly large number of clients are connecting on Wi-Fi 4 and lower protocols. So even though we talk about Wi-Fi 6, Wi-Fi 7, there's still a large population of clients, which is essentially 11N clients, which are still in the field. And I think the learning here is that 11N continues to dominate, and backward compatibility is important. And we have to make sure that the network supports the older clients, because the rate at which the clients are refreshing still not as high as we see in other countries where the adoption of newer technologies is faster. If you look at how the clients consume the data, this is a cumulative distribution. So the percentage are cumulative in nature. So as you go up, see the numbers get added up. But the point to note is that most of the clients transacted relatively small amount of data. Remember, there is mobile data offload. So even if you are not manually connecting to the Wi-Fi, in the back end, your phone, if it has Wi-Fi enabled, would get offloaded. So your WhatsApp messages, other transactions would be going over the Wi-Fi. So that kind of explains that most of the people would not even have noticed. In fact, I was talking to one delegate in the morning. He said, I went to the Kumbh Mela, but I didn't care about the Wi-Fi. But most people didn't care because their connection was automatically offloaded to Wi-Fi. They would not even have noticed. So even if they made a call, most likely it would have gone over the Wi-Fi network. They didn't have to do any password entry or connection or portal to do it. So maybe that's why they didn't notice that there was anything special about it. But we also see that there is about 10% of the clients which consume more than 2 MB data per day. So this is actually on a single day, right? So the numbers are for a single day. There's also that 1% crowd you see here, which is consuming more than a GB per day. So even in a place like that, where everybody is busy doing spiritual stuff, there are people who need Wi-Fi for other things. So you see that there are people, about 1% of the population, which was consuming more than a GB of data per day. This network was a dual stack network. So the access points supported both IPv4 and IPv6. So when we looked at the data which was transacted over IPv4 versus IPv6, we found that even now, despite a lot of clients which are supporting IPv6, still about 35% of data only was on IPv6. So from a client perspective, even though user didn't have to do anything special to connect to IPv6 network, I think the conclusion that I can draw here is that the client-side support on IPv6 is still not there yet. So we do have clients which are basically IPv4 only. So there's still some way to go before we move to a full IPv6 network. And when we look at a frame level, right, how the packets are marked as they flow between the access point and the client, we found that barely 5% of the frames that we saw are actually marked video and voice. Rest of the frames, almost 95%, they are essentially best effort and background. So that kind of tells us that from an application point of view, applications are not leveraging WM marking as much as we would like, right? Essentially, applications are just dumping data which are going either as best effort or background traffic, and hence we are not able to apply any of the WM-based QoS mechanisms on the data which is either on the downlink from AP to the client or on the uplink from the client to the access point. So in both directions, we find that WM really is not making an impact, mainly because applications are not marking those packets. I think the heading is wrong. Here I'm trying to analyze what was the packet failure rate, right? So we looked at all the packets that flowed on a given day, and we found out that, and this is at AP level, what on the y-axis you have percentage of APs, and x-axis the percentage of packet failures. We found that even in this kind of a congested, large-scale network where not everything is in your control, we still be able to achieve a packet failure rate of 5% or less in almost 98% of the APs, which kind of tells us that even in such a challenging environment, the performance at the frame level was fairly robust, right? So we are able to achieve very good, frame success rate even in such a challenging environment. So what are the takeaways from this case study? So I would say 3 points that we often say that, Wi-Fi is designed for indoor, Wi-Fi does not work outdoor. There are all these challenges. I think given that in such a large scale network, over a sustained period of time, we're not talking about 1 week, 2 weeks, we are talking about 45 days. We are able to sustain that many number of connections. We are able to achieve pretty robust performance across various generations of clients in terms of Wi-Fi. So outdoor Wi-Fi, is not really that bad. It does a pretty decent job if designed properly, if the network is designed properly. And second, I think we all know that 5 gigahertz is carrying the bulk of the load. And the good news is that the government has recently announced that, delicensing of at least unified band is on the way. So hopefully we'll get some more spectrum so that we can, get more bandwidth on the Wi-Fi side and be able to support these kind of applications better. And the third point is that the client system is still very diverse. When we look at the protocol support, when we look at IPv4 versus IPv6, over multiple dimensions, we find that there is a lot of diversity in terms of what capabilities the client have. So what it means is that from a network design perspective or a AP implementation perspective, maintaining support for a wide variety of clients is really important if you want the network to work. So it's not just I deploy a Wi-Fi 7 AP and I expect that all the clients will be magically get better performance. That's really not going to happen, because we have to make sure that we support all the different types of clients. Of course, it brings inefficiencies in the network, but we cannot force users to upgrade to newer systems, especially when you talk about a public network. In an enterprise network, we can control what devices employees use, but in a public network, we have to live with whatever the customers are connecting to the Wi-Fi with. And I think what is unwritten here is at least what I didn't put here. The unwritten takeaway from this is that you can depend on HFCL to deliver high quality Wi-Fi even in the most challenging of environments. You can find more details of this event and how we deployed in this case study, which is linked on the website. And that's all from me.
Thank you. Thanks, Nadeem. So unlike WLPC or places where Super Bowl case study, we thought maybe this is our case study, which is unique to India, and maybe throw some lowlights. So any questions, please put up your hand. I have get a mic for KK and Jatin. A quick question, was the operator happy with this? Please get a mic to Jatin and KK. Please, you'll have to somehow get a mic. No, you have to get a mic. Yeah.
Yes,
please.
I think the short answer is yes, because if you see, in this kind of network, if you have so many users on cellular, it's almost impossible to carry the traffic only on cellular. So this provided a way by which operator could decongest their cellular spectrum for higher priority users for other applications. So in that sense, this was a success story from the operator point of view.
Okay, so KK?
Yeah, so Nadeem, you said that access categories base 95% were mostly best effort and background. And then voice and video were less than 5%, and applications are not properly using. My only question is, if, as per what you said, mostly people didn't know that they were connecting on Wi-Fi and the data was mostly the applications data, would you expect them to be BK or even voice video? They may not use it, is what I thought.
So what I'm saying is that, I mean, people maybe are using applications like WhatsApp or, other applications. And at the end of the day, it is the job of the application developer to make the use of the lower layer resources, right? So if the application developers don't prioritize the packets as voice or video, then the access point cannot do much, right? For them, every packet then becomes the same.
Yeah,
So
but it's primarily the data, right? So
Yeah.
WhatsApp or other things is primarily the data,
Yes.
so they may not want to
But
classify it
calling
as,
is an important part, right? If any in this network, you will have voice calling, right? In this kind of, because this is a mobile data offload. So this is not your public hotspot network where I would connect to browse. Here, most of the people would not have noticed and they are on Wi-Fi. So whatever transactions they are doing are going on Wi-Fi, even if they are calling somebody on the phone. So there would be a traffic which is mixed, not just data traffic.
Jatin?
Yeah, I was wondering because your UBI, I'm assuming, was also happening on 5 gigahertz.
Right.
So how much of this traffic that you showed that there is a bulk of 5 gigahertz traffic, how much of that was the UBR traffic itself?
This is only the traffic between client and AP. So whatever data is there is not traffic which is between the UBR and whatever is on the other side of the UBR, which is another UBR.
Okay. So the follow-up question to that is that if you did not have UBR, do you think you could have got better throughput on this, or is it just based on load right now?
No, I think UBR itself, the one we deployed, was capable of 700 Mbps to 1 Gbps throughput. So UBR was not the bottleneck here. We had enough capacity on the UBR to carry the traffic.
Madan?
Yeah, actually 2 comments in the question. So comment 1 is like the WMM traffic, what we were talking about. As someone rightly pointed out, so irrespective of application setting, so we have enabled a solution in Samsung, which Divya was talking. So even if you do a, let's say WhatsApp voice call or a video call, we are automatically upgrading to voice or video category. So I think probably they were using for message or those kind of traffic only. So
No, but that's only if they use your phone, right?
I'm assuming at least 20% in Mahakumbh at least.
Okay, yes.
At least. So I mean.
That too in S25.
No, it's in all the devices.
All devices, okay.
Yeah.
Yeah,
So
that's good to know.
the
Because,
WMM is in A series, M series, all the series because we want the user to have a wonderful experience. So that's comment number 1.
Yeah, so you can only mark traffic which is originating from the
Yes,
client.
only the uplink.
But most of the traffic is actually coming from the other side.
reverse,
So
yes.
the application servers also have to do the same thing, which probably is not happening.
Yeah, right. That's comment number 1. Comment number 2 is like, again, station to access point. So depending on the type of the operator. So between station to access point, we enable only V4 or V6. For example, say operator 1, we might enable always V6, and operator 2, we might enable V4 if it's having dual IP capacity. So maybe that's the reason you see a lower IPv6. But if it's like on the cellular, if you have captured, mostly traffic could have been V6 because the 5G, the major 2 operator are using V6 mostly. So India is one of the largest IPv6. Those are the 2 comments. And the question is, can this data be open sourced, whatever you're showing? Because Super Bowl usually, as Srikanth was mentioning, Super Bowl data would be open sourced, and we used to play around with this data for not just companies. So I'm part of academia side also. So for the academia side also, we used to play around with this data.
I mean, this presentation will be available on the website if that's what you want. But you are looking at raw data or these graphs?
Raw data.
Let's talk offline.
I think, yes, go ahead.
No question. I just a comment. Because nobody asked this question, I just wanted to put it in front of everybody. 660 million visitors, only 2.5 million mobile data offload, which is less than even 1%. That's the problem of the Wi-Fi. Earlier in the day, somebody was making this comment that why Wi-Fi is not being used, why mobility gets the lion's share of the traffic. We need to really ask why Wi-Fi is not getting enabled on the devices, why people are not enabling Wi-Fi and keeping it switched on. If they kept it switched on, that would connect to the network of the operator. Operator is India's largest operator. So you can fairly assume at least 50% of the people who visited were carrying the SIM from that operator. So even if you take 330 million customers, it's still less than 1% really offloaded. So the question for this community and food for thought is that how do we make sure that people are using Wi-Fi?
So one follow-up comment to what you just mentioned. See, we saw the distribution of the client capabilities between Wi-Fi 4 and below and Wi-Fi 5 and above. Now, is it possible that there are devices that are so legacy that they don't support the features which are required to do Wi-Fi offload itself? So that's one thing that we need to think about. The other thing is that when you talked about Wi-Fi and switching it off, one of the key problems in a place like this is actually don't have places to charge. People are so sensitive about the phone battery that they turn off Wi-Fi. My colleague here actually mentioned when that is going on that, I always turn off my Wi-Fi because I'm worried about the charge on the phone. So that's one more reason why we see a lot of people turning off their Wi-Fi or Bluetooth or even location services all the time. So in fact, I was wondering, is it possible to figure out if there were devices that were not even capable of doing offload?
So we don't have the model data, but yeah, it's quite possible. There could be devices which don't support eSIM, for example.
Yep, I think
SIM
that
based.
could be a problem, yeah. Last question for Nadeem, if there is anybody who has a pressing question, quick.
So, Nadeem, do you have any data to say the number of call admission issues, like, because the scale is too huge, like there are a lot of demand that you could not admit.
But we have data on how long the sessions lasted, right? For example, I connect and immediately somebody may disconnect. Sometimes people have stayed for 3 hours. So that level of data we have, but not at individual data sessions, you can say.
I mean, that may be answering the question, somebody may be trying to connect, but they may not be able to admit, possibly able to admit to the network.
So we have data on, people who tried to connect and failed. So that data is there, yes.
Okay.
People who may have, problems with either the SIM-based auth flow itself, right? Or somebody, I have a Airtel SIM card, I'm trying to connect to a IAP which is managed by Jio, so then obviously I will fail. So that type of data we do.
Okay, I am talking morely from the capacity point of view. Is it like we are already we are fully saturating the capacity, right? Are we hitting a saturation limit, and because of that the call could not be
So
admitted?
I looked at the reason codes for authentication failures. So I didn't find a large number of connections where it was failing because of not enough capacity. Most of the reasons I saw for this kind of behavior, either the password is wrong or the client has moved out of coverage and so on, but not really capacity related reason codes I did not see in the data.
Thanks, Nadeem.